Hello, friends, students, and enthusiasts. So very quickly, we are into the second video of this series where we are discussing about the development boards, different type of development boards which are used for making your projects and which are used for various of different purposes. So today we will be discussing about Raspberry Pi Pico boards. Okay, it's a microcontroller board. As you know, Raspberry Pi is a very popular company who made previously a board or micro computer. Okay, so this is a microcontroller board. Okay, one thing, there are two boards here. Rather, we will be discussing about three boards, three or four boards. So that is Raspberry Pi Pico 1, then Raspberry Pi Pico 2, and in the same series, you have W series also, that is Pico W. Okay, so this is a powerhouse for beginners, embedded project development. So here you can see what is there on the board, especially we are discussing about what is there on the board. And because we are all electronic students or taking this thing, so we should know what is there on the board. Where is what part is located where? That picture on the one side of the PCB. Here you can see on one side of the PCB, all the components are laid. This is W, okay? The center one, which is the steel part, that is, we call it as a wireless module. This is W board. And where you don't have this part, that means only this chip is present. That will be a plain Raspberry Pi Pico board, okay? So picture on the one side of the PCB, here you can see on one side of the PCB, also here, this is simple one, that is without W, and this is with W, that is with Wi-Fi connection also. Okay, right. Now, let's go to the next part of it, that is drive. So we will just see here exactly what we are going to discuss. We are going to discuss about what are the difference also here. This is simple one, that is without W, and this is with 2040. This is a microcontroller. Please remember, it's a microcontroller. Okay, it is microcontroller that came in the year 2020. Not very listening, only 5 years back it has come. So microcontroller chip designed by Raspberry Pi Pico. So what you have to remember, it's a dual core ARM Cortex M0 Plus processor. Okay, it comes from the ARM Cortex family. Okay, flexible clock running up to 133 megahertz. The clock is flexible. It runs up to 133 megahertz to 64 kilobyte of SRAM, static RAM, and 2 MB of onboard flash memory, that is storage. Whereas on the other side, you can see RP2350. Now we are discussing about Pico 2 board, which came just recently in 2024. Okay, right. So microcontroller chip here, the difference is the RP2350 is used. So previously it was 2040, now it is 2350. Raspberry Pi, same company, same homemade micro computers before, the same company. It is also dual Cortex M33 or Hazard 3 processor, we call it as. That is the only difference. So Cortex M0 in Cortex M33. And the processor or speed or the clock frequency can go up to 150. In previous case, it was 133. Here it is 150. The RAM has also increased, almost doubled, 250 kilobytes of RAM and 4 MB of onboard flash memory. So this is the difference between the RP2040, that is Pico 1, and the Pico 2, that is RP2350. Okay, that is the main difference what I wanted to tell you. Right. So drag and drop program using mass storage over USB 26 multiple function GPI pins. All engineers should know this particular points. That is, what is it? 26 multiple function GPI pins. Actually, it is more than that, but some of them are for analog controls, for analog pins, we call it as. Okay, GPI pins. So you can use all input and output connection from all this 26 GPI, in which 2 SPI, that is serial, and 2 I2C, that is a protocol, UART, 3 12-bit ADC, and 16 controllable PWM channel. So this makes 226. So Raspberry Pico W, we'll discuss about that now. Because I told you this, both of them, that is 2040 and 2350, Pico 1 and Pico 2, and you have Pico W in both 1 and 2. Okay, so Raspberry Pi Pico, what is the difference? You have a steel sort of a plat. This is W, okay? That is a Wi-Fi chip, okay? You have a Pico W added on board, single board, that works on 2.4 gigahertz or 2400 megahertz wireless interface, right? That is nothing but 802.11n, okay? You have to remember this, 802.11n, using the Infineon CYW43439 while retaining the Pico form factor. The same it is for both the thing 1 and 2. They will be using the same Wi-Fi chip. Okay, that you have to remember one. All right, so we'll go to the next one. What is the next one? You have to remember we should also see the data sheet and the schematic diagram. So I have just given you a schematic diagram here of a Raspberry Pi 2040. Now, this explaining about this, it will take a little time, but I will not explain you about these things. Let's do one thing. We'll go to directly to the picture, that is to our lab. I will show you I will tell you about the boards. Okay, so we are seeing our live board, that is RP2040 board. Okay, so this is a PCB on which the embedded system PCB we call it as, and on which the whole circuit is made. Okay, it's a dual-sided PCB. That means the track will be there. Of course, the component has not been placed on the other side. The main components are on one side. But please remember, they gave a provision. And other side, please remember all the information or silk screen. That is this writing, we call it as a silk screen. It is given on the other side. Okay. Now we'll discuss about this. What are the parts? So first of all, you have to understand what are the IO pins. So this side 20, that side 20, to total 40. Now, this is the main part, that is your USB connector. Okay, micro USB connector. So nowadays you are also getting a C-type connector also. Okay, so what are the important parts? The very important part, this is microcontroller. What microcontroller? 2040 microcontroller. Okay, adjacent to it, there is an oscillator that is which controls the microcontroller. What is the frequency of the oscillator? It is 12 megahertz. Okay, but it is variable. Please remember, as we have studied, it is a variable type of this thing. So these parts, small parts, are nothing but support components which will be there. Now adjacent to this, this is the one. This is the one. Okay, where I'm putting my screwdriver, showing you on the screwdriver. This is your memory. Okay, this is your flash memory. We call it as a flash memory. It will be just near to this. This is boot cell button. That is a sort of a reset type of button. Reset is not given in this one, but we call it as a boot cell button. Okay, what is boot cell? For flashing and booting purpose, we use this boot cell button. Okay, not this thing, reset button. Okay, anyway, so this is your flash memory. This is the microcontroller, right? Not processor. This is a microcontroller. Okay. These components, you can see here from there here to here. This is related to your power and your debugging. Okay, but it's not debugging exactly. LDO pins, we call it. If connected, suppose this connector is connected. In other case, we have seen the FTDI IC will be there, FTDI IC in Arduino and all. But here also you have the same sort of this thing, but it will be combined together. There's one small transistor over here. You can see here, it's a regulator, that is 3.3 volt regulator. Okay, so this is power and regulator. One LED is also given over here. Now, what are the problems? I will just tell you, please listen carefully. Before that, what is the difference between this board and this board? What is the difference between this board and this board? Now, very important. Only everything is same. Only difference is you have a Wi-Fi connection. Okay. This side you have a Wi-Fi antenna. These are the Wi-Fi antenna which is there. Two capacitors are connected. Two sides. This side. This is nothing but an internal on-board antenna. We call it as. Okay. Here you don't have that thing. Okay. Right. Okay. Everything same. Nothing is not much of a difference. Pin configuration. I'm not going to tell you. It is already written here on the back side. Okay. Now, I will tell you about the problems and you have to be very, very careful. What are the problems like and what you have to be careful about? Please see this carefully. So you have on the left hand on from this connector, that is a micro USB connector. On the right hand side, 1, 2, 3, 4, 5 pins. These are the power pins, and rest of them are input, output, TX, RX, and I2C, and all different type of protocol connection with grounds also. Right? Multiple grounds will be given in the board. So these are the power related connections that you have to remember. 5 this thing. You have to be very, very careful while giving the power. That is, the first one is from USB power, it is directly connected. Okay, third pin is ground, and the rest of the other pin, that is the second pin, also 5 volts, and rest of them are 3.3 volts. One is for giving supply and one is for taking supply, right? Okay, now we can give both the supplies from this thing, but you have to remember that when you are giving a supply, you should check or you should see that the sensor or any other part should not consume more of the power. Otherwise, this IC or this diode, which is here, it gets heated up and it may get short also. So this is a very common problem. This transistor is very low. That means it can handle only up to 300 milliamps of current. Okay, it will not handle more than that. So you have to be very, very careful about the power part. Usually nothing happens to this IC. This IC goes, the full complete this thing is dead. Okay, so time to time when it is required, you can press this button. When LED will not be continuously on, please remember this is not a power LED, so this will not be on continuously. When only you give connection or you do a program, then only it will be on. And one more thing very important, C++, C++, and MicroPython, both these boards can be programmed with that, MicroPython and C++. Since this is a dual core, both of them are dual core. Okay, you have to be very, very careful that you should not exceed 3.3 volt more than that is the. So IDE, that is the working of this software, C++, MicroPython, and also Circuit Python. Okay, it works on Circuit Python also. Okay, that is where. So 20 this side, 20 that side. Okay, so 40 it makes to 40 pins. So I've given you a little idea about this. I hope you understood this. While few of the points you have to remember very well: the power part, the connector part, the LED part. It doesn't come directly. It's not a power LED. Boot cell. Second, you can program it with MicroPython, Circuit Python, and C also. There is an oscillator that is which controls the microcontroller. What is the frequency of the oscillator? It is 12 megahertz. Okay, but it is variable. Please remember, as we have studied, it is a variable type of this thing. So these parts, small parts, are nothing but supportive components which will be there. Now adjacent to this is the one. This is the one. Okay, where I'm putting my screwdriver, showing you on the screwdriver. This is your memory. Okay, this is your flash memory. We call it as a flash memory. It will be just near to this. This is boot cell button. That is a sort of a reset type of button. Reset is not given in this one, but we call it as a boot cell button. Okay, what is boot cell? For flashing and booting purpose, we use this boot cell button. Okay, not this thing, reset button. Okay, anyway, so this is your flash memory. This is the microcontroller, right? Not processor. This is a microcontroller. Okay. These components you can see here from there here to here. This is related to your power, and your debugging. Okay, but it's not debugging exactly. LDO pins we call it. If it connected, suppose this connector is connected. In a